Today we are on topic A, 1/10 or 10 times the value. So what we're going to look at is I'm just going to give you some examples before you start on your work, and then you're going to try to figure out if it's 10 times or if it's 1/10 the value. Let's begin. The first thing you have to know is it has to be the same digit. So if you are comparing a 2, you always have to compare it to a 2. So you cannot compare a 2 to a 3. If I was going to say 23, I cannot compare alright, so we've got 23 and 452. I can't compare the 3 to anything because there's no 3's in this number. I can only compare the 2's to see how they are similar. This 2, if you remember your place values, you have 1s, 10s. This is in the 10s. So its value is 20. This one, 452, its value is in the 1, so its value is 2. The way we need to look at it, this is the little cheat I use, alright? Because sometimes saying 10 times 1/10, it gets a little confusing. But if I say 20 is bigger than 2, then I can say 20 is 10 times 2. And look at the words. 20 is 10 times 2. 10 times 2 is 20. 10 times 2 is 20. It works out because in math, is the same thing as an equal sign. Alright? So sometimes just using little things like that makes the identification a little bit easier. But this same sentence can be written another way. If you reverse where the numbers are, you would say 2 is 1/10 times 20. 1/10 times 1/10 of means times. So 1/10 times 20 is 2. Now we are going to learn how to officially multiply fractions later on this year. This is not about multiplying fractions. This is all about place values. What place value is it in? Another way to look at it is decimals. Moving that decimal one place to the left or right to make it smaller. It has nothing to do with multiplying fractions at this point. When we get to fractions, I can prove it mathematically that this is exactly true. I don't want to get into multiplying fractions at this point because it will become a little bit confusing. We are just based on our number system is based on a base 10 system. So everything is based on 10. That's why when we count to 9, we have to carry a 1 to the next column to get to the 10s. When we get to 90, we have to carry a 1 to the next column to get to the hundreds. So it keeps going like that. It's a very wonderful system. That's why we use it. It's easy to learn. And it makes moving decimals and the connection between one place value and the next easy to understand 10 times. And again, it has to be the same digit. Let's do another example. Okay, so your number examples are 4,562, 3,346. The 4 in this number is worth 4,000. The 4 in this number is worth 40. So 4,000, 40, it's more than one space away. This one's in the tens. This one's in the thousands. Okay? And if you look at it this way, 4, 0, there's 2 zeros. So that means it is 100 times. And if you look at it, 40 times 100, okay, that is 4,000. So 4,000 is 40 times 100. So anything with a 1 and a 0, you can do this with. Again, we're not going to deal with any other numbers. We're not going to deal with 20 times. We're not going to deal with 40 times. We're not going to deal with 50 times. It has to be a 1 and a 0, because with the base 10 system, we're looking at place values and moving that decimal. So at this point, these are a couple examples. I do want to do one more example, and that would be, instead of just picking digits out and comparing them, it's actually getting a whole number and making its value either 1/10 the size or 10 times the value. So let's make it smaller first. All right, smaller means 1/10. So if we're making 23 smaller, everything has to be shifted to the right. So the decimal is here, so the 2 goes to the ones place, and the 3 goes to the tenths place. So again, 1/10 of 23 is 2 and 3/10, 2.3. Right? If we wanted to make it bigger, it would all shift to the left. And that would make the 2 go in the hundreds, the 3 go in the tens, and nothing would be in the ones. That would be 230. So if I wanted to find out what 10 times the size of 23, it would be 230. It's all about shifting place value one direction or another. Another way to look at it would be moving the decimal. Then, when you're done, check yourself. Did I do it right? If I am looking at something 10 times the size, ask yourself, did it get bigger? If it didn't, you moved it the wrong way. If it is 1/10 the size, ask yourself, did it get smaller? If it didn't, you moved it the wrong way. In math, you always have to go back and ask yourself, is my answer reasonable? Does my answer make sense? If it doesn't, go back and change it. Too often, we just put an answer down and move on. I don't want you to do that. I want you to look at your answers, look back at the question. Did I answer the question? Did I answer it in a way that makes sense? It's not going to be too difficult for you guys to go back and review yourself this year. Thank you. It's time for you to move on to the in-class practice.